Let's talk about how imagery is made in astronomy. The particular examples will be from the Hubble Space Telescope, images that are familiar to many people. But the principles here apply to making color images from any telescope, including ground-based telescopes or a hobbyist telescope that an amateur astronomer may use. Color imagery is one of the greatest products of astronomy because the images are visceral. They stick in the mind and they stick in the heart, and they summon up worlds that we may never visit. Color imagery from something like the Space Telescope is made quite differently from the color image on your TV or your phone. There, different pixels are addressed by the different colors, red, green, and blue, simultaneously, and the eye pieces together that information. In an astronomical telescope, the light is filtered, so colored glass, red, green, blue, or some other color, is placed in the light path of the telescope, and the detector only receives light of that color. So sequentially, with a series of exposures, light of the different colors is received. Those separate images, one each in a different color, must then be combined afterwards in a computer to produce a full color image. The important thing about Hubble imagery is that the color imaging is exact and astronomically correct. You could assign any color you want to an image taken through a filter and make lurid false color images. In fact, for X-ray and radio astronomy, which is dealing with invisible waves, you have to assign artificial and false colors to the data. There's no other way to see it. But for visual imagery in astronomy, professional astronomers appreciate that the Hubble Space Telescope project chose not to use lurid color tables or false colors, but try and represent the colors as close to the way you would see them, if your eyes could be so sensitive. We can go through the series of steps by which a beautiful true color image is made with Hubble imaging or any other telescope. The example being used here is the gorgeous image called Pillars of Creation, a region of star formation. The first thing to realize is that the smooth, seamless, and often very large image that you see on your computer screen was probably pieced together from subtiles, or mosaicked. The individual detectors, or CCDs, on the Hubble Space Telescope have gaps between them, and those gaps have to be removed to produce a seamless image with no gaps or tracks or lines in between. Each individual image is essentially not in color. It's a black and white image in grayscale, where the light varies from black to white. It is taken through a color filter, so we can assign a wavelength to the data that records intensity. Hubble images are quite ugly in their raw form, as you can see here. Basically, the reason is that cosmic rays, high-energy particles that reach the Earth's atmosphere but don't reach the Earth's surface, are abundant in Earth orbit, and so Hubble's detectors suffer many, many interactions with cosmic rays, rivaling the interactions they suffer with astronomical photons from the distant universe. What this looks like in the raw image is a blizzard of dots and specks and even some horizontal tracks representing cosmic ray interactions in the silicon. This is noise. These are ugly artifacts that we want to get rid of before we can even approach a nice image. The way to do this is to take multiple sequential observations with the same exposure time, and then filter these for the cosmic rays which never occur in the same place on the silicon surface. In practice, 3 to 5, usually an odd number of images, is sufficient to get rid of 99 or 99.9% of all the cosmic rays, cleaning up the image wonderfully. Of course, by adding together the separate images, you also benefit from the sum of the exposure time of the individual exposures, reaching even deeper into the sky. There are other artifacts on these images. Around the edges you can see noisy regions which represent the way the data is scanned out of the CCD. Those must be clipped off to make a clean image. The next correction is quite subtle, and the average person might not notice it, but the Hubble optics are not perfect. They do distort the geometric grid of positions on the sky, and that distortion must be taken out. So the image is remapped to produce perfectly two-dimensional images of angles on the sky. The final part of the process is that each of the black and white images, taken through a different colored filter, is assigned a color, and those are combined to get the true color image. The weighting of those different colors can be varied to adjust the color balance, and the result is something that resembles a true color image of the sky. This image, the Pillars of Creation, was created for a press release by Jeff Hester, who works up the road from me at the Arizona State University, and the methods he used were so popular and so effective that they were adopted by many other researchers. And so routinely, Hubble images of any region of the sky taken through separate color filters are combined in this way to produce true color images. The Hubble project releases new sets of images in their public data virtually weekly, and they collect the best of them into treasury collections that form the most spectacular images that you will typically find in planetarium shows and on the screensavers. Everyone has their favorite Hubble images. I can share some of my favorite with you, but you may have your own. There are literally thousands of color Hubble images after its 2.5 decades of work. They cover everything from the nearby solar system to galaxies at the dawn of time. The Hubble Space Telescope project produced a video, Hubble Revelations, which summarized the impact Hubble had made on almost every field of astrophysics. A truly impressive legacy for a telescope which, remember, is not even in the top 50 in terms of the size of its primary mirror.
Discovery, go for Hubble release.
The first of NASA's great observatories is now on station at 330 nautical miles above the Earth.
Thank you very much for the ride.
The color imagery you see from Hubble Space Telescope and other large ground-based telescopes is not just eye candy. It also contains astronomically important information. Often the blue channel is associated with an oxygen line or the red channel with a hydrogen line, so you can learn about chemical composition of the glowing gas when you see a nebula. Hubble has produced many of these gorgeous images over its 2+ decades in operation, and it's meaningful that they not only provide an aesthetic experience but a scientific experience as well.